In lesson 61, we're going to look at how do we determine if a quadrilateral is a parallelogram. So in order to do that, the first thing we need to know is our properties of parallelograms. And remember, the main thing about a parallelogram is that opposite sides are parallel. All right, this isn't one of the properties. That is just what a parallelogram is. Opposite sides are parallel. But now we are determining if a quadrilateral is a parallelogram. So the first property is that both opposite sides are congruent. Okay, so that would look like this. Opposite sides, those are congruent, and those are congruent. If we see that, we would automatically know the quadrilateral would be a parallelogram. The next one is opposite angles are congruent, both pairs. So here's an example of opposite angles. They're congruent. These are congruent. Therefore, we can know that this quadrilateral is a parallelogram. Third one is one pair of opposite sides is parallel. So let me draw what that would look like. That might look like opposite sides are congruent and parallel. If we know that right there, we automatically know that this is going to be a parallelogram. We know these sides are parallel and congruent. And then the last one, the fourth property, the diagonals bisect each other. Remember, bisect means they cut in half. Then this quadrilateral would be a parallelogram. So now that we know our properties, let's look at a couple of examples. The math is going to be easy on this. You just got to know the properties and how to solve. Example 2 says, in quadrilateral PQRS, PQ is congruent to SR. Drew little tick marks there. It wants to know, is this a parallelogram? Is PQRS a parallelogram? I'll just write that, whatever. So we've got a lot of information here. So how can we use what we know to figure out if it's a parallelogram? Well, let's kind of go back to some of our properties here, see if we can see both. Okay, the first property was opposite sides. Both pairs of opposite sides are congruent. Well, we only know one pair of opposite sides is congruent. So we can't necessarily use that to know that these are congruent. However, we can, since these are congruent, we can find x. So we would set these equal to each other. 5x minus 38 equals 3x plus 2. And then you can solve minus the 3x. That's 2x. Add 38. That equals 40. So therefore x equals 20. We'll keep that up here. Alright, now that we know x equals 20, let's see if we can use our other properties to determine if it's a parallelogram. The next one says, opposite angles, both pairs are congruent. Well, over here we are given opposite angles. So what we can do is see if these are equal, P and R are congruent, and see if S and Q are congruent. Since we know the value of x is 20, we plug those in. So let's see if angle S is congruent to angle Q. Put a question mark there. Angle S is 3 times 20. That would be 60. And that's 5 times 20 minus 40. 5 times 20 is 100 minus 40 is 60. So therefore, these are congruent. So we got one pair of opposite side angles congruent. Now we got to see P and R. So P is 6 times x, so 6 times 20. 6 times 20 is 120. Doing some mental math here. And that is equal to 5x plus 20. So 5x is 20, and then plus 20. Why don't we keep doing that? Okay. 5 times 20 is 100, plus 20 is 120. So therefore, both pairs of opposite angles are congruent. So it is a parallelogram. And that's how you would do that example. Let's look at the next one, example 4. Let me see what the question's actually asking. It wants to know if our STU is a parallelogram. So we're going to check out and see if our STU is a parallelogram. Well, let's look at what it gives us. It gives us a bunch of diagonals here. What do we know about diagonals? They bisect each other. So we're going to have to prove that these are congruent and these are congruent. So there's different ways that you could solve. You could actually set these equal to each other and see if it works. Or we could solve for x by doing, since these opposite sides are congruent, we can say that 2x plus 3 equals 9. Subtract 3. So x equals 3. So that's going to be what we use to solve. So now let's see if RV is congruent to VT. Well, we plug in 3 plus 3, that is 6. And then 2 times 3 is also 6. So therefore, these diagonals are bisected. Let's check the other ones out. Plug in 3 here. 3 times 3 minus 2 is 9 minus 2, 7. Hopefully you can read all my writing here. 4 times 3 minus 5. 4 times 3 is 12. Minus 5 is also 7. So therefore, it is a parallelogram. Parallelogram. There you go. And so that's how you solve these examples. You just got to make sure you know your properties of a parallelogram.